This is the complete outline of everything on our final test. This test is very cumulative in nature in the sense that a lot of what you learned this semester is drawn upon to answer the questions. And so it's a really good test, but it's a challenging test. I did have one student that took, one of the first students to take the test. He was either the first or the second to take the test once it opened up. And he did say, you were right. Yeah, he did good, he said, but it was the most challenging of all the tests we've done this semester. I do think it becomes a lot less challenging if you're here today and you've reviewed and done the practice test. The practice test, as always, will get you what you need to get. Okay? In general conference on yesterday, I can't remember which session, but it was President Ballard, the president of the Quorum of the 12 Apostles, and he talked about, at one point in time in his life, he wanted to visit this widow. He felt a spiritual impression to do so, and he talked himself out of it, as we've all done before. Raise your hand if you've ever talked yourself out of the voice in your head. Yeah, okay. We've all done it, all guilty. And it was snowing that night, it was late, and so he said he'd go in the morning, and when he went, she had passed away, and he obviously was emotional about that and regretted that. And so one thing I'll share with you is that, unlike the Holy Ghost, I'm right here. And so when I tell you to do something, if you're talking yourself out of it, man, that's even worse, okay? Because while I'm not as holy as the Holy Ghost, and I'm not encouraging you to do spiritual things, I am straight up telling you things to do that are going to benefit you. And if you ignore them, now you know that wasn't just a voice in your head. It was a literal voice telling you, here's what you need to do, okay? So one of the things I'm telling you is take the practice test. Why did we make it extra credit? It was not to make it optional. Okay, and that's the one bummer is that, because it's extra credit, it by default becomes optional. But, and maybe we require it, but how do you require it for 0 points? It's just kind of stupid. So the point I'm making is we wanted to reward you with some extra credit points at the end of the semester, help your grade. But a practice test in this class is way too valuable to not do. And the practice test is super in line with the test. So we're going to go through this. Problems numbers 1 through 11, as we've already discussed, come from sections 5.1 through 5.5 in the book. The first problem is a common factor problem. The second is a grouping problem. All the rest are just factor completely. We're going to see all 5 methods in 1 through 11. Let's go ahead and look at the practice test. I will scroll around here. I told you that my screen isn't working. So my screen, look at my screen, is black and blank, and it will not work. And I've tried to get it to work many times today to no avail. So it is, there we go. So I can still function without that. So look at problems numbered 1 through 11 on the practice test. Look at 1, factor by pulling out a greatest common factor. 2, factor by grouping, just like the test format. And then 3 through 11, factor completely. So if you do these 11 problems, you are in very good shape for the first 11 problems on the test, okay? Everything isn't identical, but oh my goodness, it is super preparatory. Look at 12 and 13. 12 and 13 come straight from section 5.6, our lecture last time, solved using the principle of zero products. Let's look at these 2 problems. We have 2 parentheses being multiplied, they equal 0, therefore x minus 4 equals 0, x plus 12 equals 0. We can solve each of those. R times r minus 24 equals 0. 2 factors being set equal to 0, either r equals 0 or r minus 24 equals 0. We can solve. We get r equals 0 and r equals 24. Super easy. 2 problems on the test, just like that. 2 problems on the practice test, just like that. Okay? That's problems numbered 12 and 13 on the test, 12 and 13 on the practice test. Okay? I'm going to choose for you today what we go over. If you're like, hey, I really want to see a method 4 factor problem, we most assuredly can take some time to do that. But first, I want to get through all that we have up there. Is that? Am I starting at 14 there? Okay. 14, 15, and 16 on the test. You look over here. 14, 15, and 16. The directions are just like the directions on the practice test. It says solve by factoring and using the principle of zero products. This is straight from 5-6. This is our 4 steps to solving a quadratic equation. This is 14 through 19 on the practice test. So we give you 6 problems to practice, 3 on the test. We've got problems that are basically, we've got to use all 4 steps, right? We've got to get them in standard form, factor them, then apply the principle of zero products, then solve each linear equation. In the directions here and on the test, they kind of give you a hint of, hey, you're going to have to both factor and use the principle of zero products. Problem number 20 is like problem number 17 on the test. It is to find the x-intercepts. We went over this in 5.6. So what's interesting, if we look at this, we reviewed 1 through 11 on Wednesday's class last week. We reviewed 12, 13, 14, 15, 16, 17 thoroughly in class last time. And so how do we find x-intercepts? This problem, we found a couple little frustrating errors. That should say equals 0. So go ahead and on your workbook right there, write equals 0 on that, if you would please. Does the haircut make me look older or younger? Tell the truth. Older? Younger? Oh man, we got a debate here. What? What do you think, Faye?
Older.
Older?
Still looks great for your age, though.
What's that?
Still looks amazing for your age, though.
Well, thank you, Faye. You get an A. You may be dismissed. Don't even worry about the final. Just okay. No, I was getting sick of it. I've been growing it out for like a couple of years, and this is kind of my go-to haircut, but it was getting crazy. It was all winging all over the place, wild. I was like, I'm so sick of it, so I just was like, cut it all. Then when I go surfing and you get out of the water, it just dries. And it's good. You don't have to do anything. So. All right. So problems 21 through 25. Actually, there might even be more here. Let's go ahead and scroll. What's up, bro? It's going good. So let's go to the board. Problems number 18 through 20 on the test are word problems. And this was the portion of class that we didn't have enough time to really get into, and I asked you to watch the video. And this is where I go back to that kind of Holy Ghost conversation, is that if you didn't watch the video, you had a very direct voice tell you to watch the last 10 minutes of the video, and you should have. And I want to remind you of something powerful. And I know that we talked about this, but it's the concept of kind of water and how we can liken it to knowledge in the brain. Did everybody sign this? Did you sign this? Okay. Is this today's?
Yes.
Yeah, sure. So if we go out and we water the lawn today, and obviously it's frozen out there, but we'll pretend we live in California or something. And we water the lawn today, and we take our hose and we just go over one spot. The water's just gonna flood off, it's gonna run off, and stuff like that. But then if we turn on literally a sprinkler that just kind of goes back and forth, we can put water on that lawn for hours and hours and hours. And it's really interesting because it has, if you look at this, it's kind of fascinating. Here's your lawn, going like this, okay? But underneath, it's got these little capillaries that can drink up, in the soil, the liquid, okay? And what happens is when this first layer gets saturated with water, it has to drip down to the next layer and then fill that up, and then drip down to the next and the next and the next and the next, all the way down till we get inches deep, okay? But what's interesting is when we pour water over the top of the lawn, it fills these up so fast it cannot drip down slowly to percolate, and so it just runs off the top, and we get flood effect. Knowledge is very similar to this. So what's interesting is if we time how we sprinkle on this, the water will go down and then it'll drip to the next, and it'll percolate down, and that'll percolate down, and we can literally put inches of water into the soil if we do it methodically over time. Knowledge is the exact same way with the brain. If we feed you knowledge from a fire hose, and it's just coming off of you, then very little absorbs, and most of it just goes off the top. We talk about drinking from a fire hose when it comes to knowledge a lot of times when we're in new job training or something like that, where they're like filling you for 48 hours straight with everything you're supposed to do in the job, which is almost ridiculous because you're going to have to go back and learn it all over, So my point is that don't ever think that seeing something multiple times is useless. It actually allows it to go deeper and deeper and deeper within. Why do you think we read the Book of Mormon and the Scriptures over and over and over again, right? Over time in our lives, it sinks deeper and deeper within our souls and becomes more meaningful with the experiences that we can associate it with at the time that we're reading it, because our experiences are constantly changing too. So when I tell you to watch the video, I'm just telling you today, if you didn't watch the video, we will go over these problems in class. And then I recommend go watch the video about it. And then do the practice test. And then you will have had 3 layers of this exposure, and it'll be better for you. So the first word problem on the test is a consecutive integer problem. And it's just like numbers 21 and 22 from the practice test. So we're going to do number 21 right now. The product of 2 consecutive integers. And I'm not going to write these problems on the board. They're going to be, they're right there for us. So I'm just going to do the problems on the board with you. But I would recommend that you do these right now. Anything I write on the board today is worthy of taking notes or pictures, or both. Writing always helps you learn. The product of 2 consecutive integers is 89 more than their sum. Find the integers. This is number 21. And it is a consecutive integer problem. The first thing we have to do in any consecutive integer problem is we have to define what the integers are. What's our first integer? What's our first integer?
X.
And why is it x?
We always start with X.
There we go. It is x. And it's because, and I'm going to write this over here, we always start with x. Oh my goodness, we sang that, we chanted it. We went over that so many times. And we said this test is very cumulative in nature. There's some cumulative knowledge right there. So what's our next one? What's our next integer?
It's also another variable.
Is it y?
Yes.
No. Say it louder, I hear it.
X plus 1.
It's x plus 1. Very good. It's x plus 1. Because, right? Like pick a number, any number. We went through this a long time ago. Pick a number, any number. 5. Okay? And what's the next number after 5?
6.
And that's 5 plus 1 is 6, right? And so that's what we mean by consecutive integers. Are we cool? Okay, we went through this back in chapter 2. So this is definitely a review concept tied into this. One of the things we discussed in the video is that in the past, whenever we dealt with a consecutive integer problem, we always had to talk about the sum of those integers. We couldn't deal with the product of them because if we multiplied x times x, we would get x squared, and we couldn't handle x squareds. 2, 3 weeks ago, 2 months ago, we could only handle linear equations. So now it says the product, if you look at the problem, and you can go back to the board here and look at this, it says the product of 2 consecutive integers is 89 more than their sum. So product is means equals 89 more than, so 89 plus their sum. Think about that for just a minute. We're saying the first times the second equals 89 plus the first plus the second. Their product is 89 more than their sum. What is the first? The first is x. What is the second? It's x plus 1. We're multiplying them. X times x plus 1. Here we have 89 plus, because it's 89 more than their sum. The first is x. The second is x plus 1. What is x times x, everybody?
X squared.
So I want you to draw your attention to this board over here. Okay, it might be kind of glary from your angle. So, sorry to make you guys crick your necks here, but here we go. Whenever we solve an equation, I don't care if it's a degree 1, degree 2, meaning it's a linear equation, it's a quadratic equation, it's any kind of equation, we always got to clean it up. We always got to clean it up. The first step is to simplify the equation. How do we simplify? We get rid of fractions, we distribute parentheses, we combine like terms. So we have this equation over here, and how do I know what to do? Well, anytime I have an equal sign, I got to clean up the equation. I have parentheses, I'm going to distribute them. X times x is x squared. X times 1 plus x. Over here, I got 89 and 1. Those are like terms. That makes 90. I got x and x. That makes 2x, right? So now I recognize that I have a degree 2, right? That means I have a quadratic. If I have a quadratic, I'm not just going to get x alone like I would in a linear equation. I'm going to get all my terms on one side in descending order, set equal to 0, known as standard form. So I subtract 2x, and I subtract 2x, and I get x squared minus x equals 90. And now I'm going to subtract 90 and subtract 90, and I get x squared minus x minus 90 equals 0. Okay? So that's my first step in solving a quadratic equation, is to get it in standard form. My second step is to factor everything. I have c equals negative 90. I have b equals negative 1. You guys know your times tables. What are two things when multiplied together make negative 90, when added together make negative 1?
10 and 9.
10 and 9 make 90, but they add together make 19. So one's got to be negative. Which one? Negative 10, positive 9 make negative 90, add together make negative 1. What do I have to put here and here? Here and here.
X.
X and x makes x squared, minus 10 plus 9 equals 0. I get x minus 10 equals 0 and x plus 9 equals 0. That's applying the principle of zero products. I solve each linear equation now by adding 10 to each side. We talked about the fascination of the human species knowing so little, but doing so much with what they know, and how we can't solve a quadratic equation, so we use factoring, the principle of zero products, to break them into linear equations. We have two answers. We have two answers because we said a degree 2 equation can yield up to two answers. We have two answers. Now, really important here. Again, if you watched the video, okay, or we were able to go through, and I don't remember each class what all we went through, but I don't think we went through this in class, but if you watched the video, you got your first layer of water in your brain, and now we can work it down deeper. If you didn't watch the video, now you're getting your first layer, and the thing that concerns me is this concept is outlined super well in the video. If you're getting it again now, it'll probably stick. It'll go deeper in you, and you'll get it right on the test. There are two answers on this problem. And here's the deal. If you're taking a multiple choice test and you say 10 and negative 9 right now, which could be viable answers on the test, the answer would not be correct, because that is not the complete answers. If you got rid of the negative answer because you believe that all negative answers are wrong, that's not true. Negative answers are right sometimes, wrong sometimes, depending on the type. Geometry problems, the negative answers are wrong because geometric shapes cannot have negative dimensions. But this is integers. And integers, the very definition of an integer is positive and negative whole numbers. So think about this. If x equals 10, then the second integer is 11. So we have 10 comma 11, and we have, if our answer is negative 9 plus 1 makes what? Negative 8. Both of those are the solutions. And so your answers to this problem are 10, 11, and negative 9, negative 8. Think about this for just a minute. Let's draw our attention up here. What is the product of 10 and 11? 10 times 11 is 110. What's the product of negative 9 times negative 8? It's 72. Okay? What is the sum of 10 and 11? 21. And the sum of negative 9 and negative 8? Negative 17. Negative 17. All right? Now, this is fascinating. Watch this. It says here that their product is 89 more than their sum. So watch this. To find out if this is 89 more than this, I have to subtract it. 110 minus 21, put it in your calculator, what do you get? Well, look at that. It's 89. 72 minus negative 17, put it in your calculator, 72 plus 17, which is 89. Look at that. Both answers are true. Their product is 89 more than their sum. Okay? Cool? All right. Let's look at this next problem, 22. I'm not going to do this one with you. I'm going to help set it up, though. This one, so the killer with consecutive integer problems is you always have to be, look at this, you always have to be aware if it's regular or if it's odd slash even. So in problem number 22, let's go ahead and just do this. If we were to set up problem 22, go ahead, you can camera on this. The product of two consecutive odd integers is 675. What's your first integer in problem 22? What's your first one?
X.
It's x because
We always start with X.
it always means always. But now what's our second integer? Instead of being x plus 1, what is it?
X plus 2.
It's x plus 2. And if it said even, would this still be the same?
Yes.
It would, because odd and even are the exact same thing. So in this instance, if you look up here, it says the product of two consecutive odd integers is 675. Product of them is 675. So you would take these two, multiply them, and set that equal to 675. Okay? I'm not going to finish this problem for you other than to say that x times x is x squared, x times 2 is 2x, and that equals 675. You got your work cut out for you on that one. The product of two consecutive odd integers is 675. Okay. All right, my friends. What's our next word problem on the test? Look over here to the board. Our next word problem on the test is a geometry problem. You're like, well, how come it says Pythagoras there? Because I just wrote them in a different order. We have these three types of problems on the test. But the next one in order on the test will be a geometry problem. And the geometry problem is just like number 23 on the practice test. So let's come back here to the board. Number 23 on the practice test. And let's do this one. Somebody read that problem out loud.
The length of a rectangle picture is 4 inches more than the width.
Okay.
The area of the picture is 96 inches squared. What is the width of the picture?
The length is 4 centimeters.
Inches
Inches.
more than the width.
More than the width. All right. So one of the things we talked about, and again, why is this test a test that I like? Because it is very cumulative in its nature. It draws on knowledge we've gained all semester. And one of the things we taught is that when we do a geometry problem, they love to use comparison statements. And one of the things I taught you is that you should always transfer the comparison statement from the test or from the book to your notes and do drop-down translation. The length, L, is equals. 4 is 4, more than, plus the width, W. So now we know that the length is 4 plus W. That's critical to your success. And we talked about that over and over again throughout the semester. We talked about DVPE. The plan is always the geometric formula. Think about this. Let's look at this problem here. What shape are we dealing with? Rectangle. And what measurement are we dealing with when it comes to the rectangle? Or what,
We're doing the area.
area.
We're looking
Area.
for its width.
Yeah. So we're looking at area of a rectangle, which equals length times width. That's the formula. And we have to understand that. We have to have that memorized. Area of a rectangle. Now, something interesting and fascinating again, if you go back to chapter 2, every time we did a geometry problem, we dealt with the angles of a triangle or we dealt with the perimeter of a rectangle. We could never deal with the area because we couldn't have, if we had a variable that was being multiplied times another variable, we would get a variable being squared. We couldn't solve that. That would be a quadratic. We didn't know how to deal with that. So what does it tell you that the area equals in that problem? Look up there.
96 inches squared.
So the area is 96, and we know that the length is 4 plus W, and the width is W. And students sometimes get a little brain wedgy when they see that W at the end. They're like, oh, doesn't matter. If the W is in the front or in the back, it doesn't matter. It still is a distributor. Do you agree with me that W times 4 plus W is the exact same thing, yes or no?
Yes.
Yeah, it's not going to make any difference. That's like 2 times 3 is 6, 3 times 2 is 6. We've talked about when we rearrange factors, it doesn't matter. It's still going to multiply out to be the same thing. So we can say that this is 96 equals 4 times W is 4W. W times W is W squared. We'll look at that. We have a quadratic equation because we have the W squared thing. In the past, we couldn't handle that. Now we can. That's why now we get to see area. So in the consecutive integer problem, you're for sure going to be dealing with the product of integers. Okay, and it's going to be just like that problem down there. The product of two integers is so much more than their sum. And in the geometry problem, you're for sure going to be dealing with the area of a rectangle because now we can multiply length times width and deal with it. So we got to subtract 96 from each side. Why are we doing that? Because we are going to get this all set equal to 0 in descending order. We'll put the W squared first, positive 4W, minus 96. We need to factor this. We know that C equals negative 96 and B equals 4. So we got to return to our times tables. Is there something in our times tables that works here? I mean, 96 is divisible by 2 because it's even. It's divisible by 3 because 9 plus 6 makes 15. 15 is divisible by 3. If it's divisible by 2 and 3, it's divisible by 6. But our times tables reveal something bigger and better. Do you know what it is? It's one of those ones that's harder to remember from your times tables. Do you know what it is?
16.
Okay, so if we have 16, how many times does 16 go in there? 6 times. So if one of these is negative, we'll say this. That would make 10. We still don't have our magic pair. There's another number from our times tables, though, that we have memorized. 8 and 12, very good, yeah. If you remember your 8s or your 12s, 8 times 12 does make 96. Negative 8 and positive 12 make negative 96, when add together make 4. I'm going to get my 2 parentheses here. I have W, so this is going to be W and W make W squared, minus 8, positive 12 equals 0. I set these equal to 0 using the principle of zero products. I solve each equation by using the balance rule, W equals 8. Here I subtract 12 and subtract 12, and I get W equals negative 12. Now, degree 2 equation, 2 answers, but one of them is not correct. Which one?
Negative 12.
Why?
Geometry.
Yeah, we can't have negative dimensions in the geometric world, so that one's out, and my answer then just becomes the width equals 8 inches, and I'm done. Because they were asking for the width. We come back to the original problem and said, what is the width of the picture? We found it. We could? All right. Your third word problem on the test is a Pythagorean theorem problem. And it's just like number 24 from the practice test. So do you see what we've done on this board here? We're really outlining everything you're going to see on the test. So I tell you, you come to class, right? You get the review. It's always going to be worth your time. So I'm going to erase this board and that board. So if you want to take pictures of what's on these boards, I'm going to get out of your way real quick. Give you a second to snap some photos. Did everybody sign the roll? Anybody not sign it? I want to make sure everybody gets credit today. Good stuff. Okay, 24, if you want to zoom in on that. 2 cars leave an intersection. One of the things I remember being in school and stuff that made sense to a teacher sometimes, they take for granted that we had no clue what the fetch he or she was talking about. And one of those things is the concept of north, south, east, and west, which makes me chuckle a little bit. because, you know, for some of you, you may be like, yeah, of course I know what north, south, east, and west are, but let's look at the board here. You know, think of the United States, okay? You know, if we're looking at a map of the U.S., where's the west coast? Point. Where's the west coast? It's to your left. Where's the east coast? It's to your right, okay? And where's North America? Up. Where's South America? Down, right? And so if we have an intersection, okay, and that's obviously the place where two cars are meeting, okay, here's car number one, okay, let's use a blue pen here. Here's car number two, okay, and this car is going north, and this car is going east. Well, the car going north, you know, and this is their starting point, okay? And ultimately, if you think about this, this is a right angle. And the distance between the cars creates the hypotenuse. Okay, so the distance between the cars, you know, is the real life application of a hypotenuse. And this makes a right triangle. When the car north has gone 15 miles, it says in this problem, so we come back here, it says two cars leave an intersection, one car travels north, the other east. When the car traveling north has gone 15 miles, the distance between the cars is 5 miles more than the distance traveled by the car heading east. Last sentence says, how far has the eastbound car traveled? You always got to start with x. Which dimension is x? Which dimension is x? It's the bottom one. It's the eastbound car. And one of the ways you can know that is, I taught you a long time ago, the last question in a word problem often represents the variable. And it says, it is posed as a question. It says, how far has the eastbound car traveled? What we don't know is x, and the eastbound car travels x. But it's telling you the distance between the cars is what? It's so many miles more than, 5 miles more than the distance traveled by the eastbound car. So that's going to be, how do we represent this? 5 plus x or x plus 5. Does not make a difference. When you multiply it out, they'll be the exact same answer. So 5 plus x or x plus 5. Now this is a Pythagorean theorem problem. And one of the things you got to remember about the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. And the killer in this is that sometimes students forget to square everything. Okay? You got to square everything. So give me a leg. What's one of our legs? 15. So we have 15, we square it, right? And what's another leg? X, and we square it. Okay? Now, the hypotenuse. What's the hypotenuse?
X plus 5
It's x plus 5. Do we say x squared plus 5 squared? No. Cannot do that. Cannot do that. We have to take the entire hypotenuse, put it into parentheses, and square it. Okay? And this draws on some knowledge from chapter 4. How to multiply a by times a by. Can't take a shortcut. We have to say this is x plus 5 times x plus 5, which is going to give me x times x plus 5 times x plus x times 5 plus 5 times 5, which is x squared plus 5x plus 5x plus 25, which makes x squared plus 10x plus 25. So, help me out. What's 15 squared? 225, is that right?
Yeah.
Plus x squared equals x squared plus 10x plus 25. That's this right there. All right, we have x squareds, which means we have a quadratic equation right now. When we have a quadratic equation, we got to get all of our terms on one side, right? So the first thing I may do is subtract x squared. Well, what happens? What happens? The x squareds, what happens to the x squareds?
They cancel.
They cancel each other out. And now I'm left with 225 equals 10x plus 25. Remember, the goal of factoring and using the principle of zero products is to create linear equations, because remember, in our human state, we're limited in our knowledge, but we blow it up, right? And so we use our tools to create linear equations. Well, do I have a linear equation now? Yeah, I do. What's the purpose of solving a linear equation? To get x alone. Now I don't want to get everything on the same side set equal to 0. I want to get x alone. So I subtract 25 and I subtract 25, and I get 200 equals 10x, and I divide by 10, and I get 20 equals x. And so the eastbound car has gone 20 miles. Now let me show you something interesting here. For those of you who kind of get things mixed up. Let's say you got to this point and you still treated it like a quadratic equation. You're like, I'm going to get everything on one side in descending order and set it equal to 0. So you subtract 225 and you subtract 225 and you get 0 equals 10x what? Minus 200. So then you factor this, right? It's binomial. What do they share in common? 10. So you get 0 equals 10. Put this over 10, put this over 10, and you get x minus 20. So we know then, right, principle of zero products, does 10 equal 0? No. So 10's gone. And then we have x minus 20 equals 0. We solve that. We add 20 to each side, and we get x equals 20. Look at that. You could follow through on the quadratic equation method and solve this. Can I share something with you, though? This won't always work. And so if it doesn't work and you get it wrong, then you're in trouble. This will always work. And the reason this won't always work is because sometimes it's just not factorable. And you have some weird, number that's like a decimal or something. And so you gotta understand, stick with this. But in this instance, it would work. So that covers, if you look at this, we've covered 1 through 20 of the test. So that leaves our last 5 problems of the test, which are retro problems from previous chapters. To really kind of emphasize the extra credit nature of this and to give you an opportunity to earn some extra points, we actually gave you 15 retro problems to practice from previous chapters. But there's only 5 on the test. So I'm going to tell you right now that 2 of the problems are laws of exponent problems. One is this goofy realtor problem. One we're being asked to graph a line, and one is a review word problem from chapter 2. We go ahead in this and we really get pretty explicit with you. Look up here. So these 2 laws of exponent problems, then there's the realtor linear model problem, which is number 7 from the review practice test. We have to graph a line. There's a couple of opportunities to do that on the practice test. And then there's an inequality word problem from chapter 2. It's an average problem. It's number 11 on the practice test. That would be like the one on the actual test. So we're going to do 5 retro problems right now. We're going to do some laws of exponents. So right now, I want you guys to do those 4. Those 4 laws of exponent problems. If you want a picture of that Pythagorean theorem problem, I would do that because I'm going to eventually erase that. Now's a good time to get that done. Fire this up. So again, you have 2 laws of exponent problems on the test. I've drawn this problem twice. I want you to see this done 2 different ways. Look up here, please. This is the power rule. And the power rule says that everything in the parentheses receives the power. How do I recognize the power rule? Because it has parentheses. Power is being raised to powers. Remember, the -3 is to the first power and has to be multiplied by the third power. A is to the 12th power has to be multiplied by the third power. I end up with -3 to the third, a to the 36th. They're probably going to multiply that out on the test. Say -3 times -3 times -3, which makes positive or negative?
Negative.
-27, a to the 36th. That will be the most likely answer on the test. This could be the answer to the test. Either one of them would work, but this will probably be the multiple choice answer that will be provided to you. Okay? They'll probably multiply it out. Reason I wanted you to do this problem here is this is -3 to the 1 times 4, a to the 4 times 4, which makes -3 to the 4th, a to the 16th. If they don't multiply this out, the answer will be 3 to the 4th, a to the 16th. Why? Because anything to an even exponent, when you multiply it out, would become a positive answer. And this is considered more simplified. Anytime you can get rid of a negative, that's simplification right there. Because negatives are like fractions. I mean, they cause issues. But this is ultimately, if you think about it, -3 times -3 times -3 times -3, a to the 16th. Negative, 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 all make a what? Positive. 3 times 3 is 9 times 3 is 27 times 3 is 81, a to the 16th. That will probably be the answer written. But this could be this is not correct because that becomes positive in the end, okay? 2 to the negative third, so this was also the power rule. This is the negative exponent rule, right? What's the answer to this one? We have to make this 1 over 2 to the positive third, right? Put it in its opposite place in the fraction and make it positive. And then we're going to multiply that out, which is 2 times 2 times 2. So this is going to be 1/8. Say woo if you got it right. Okay. This right here is another example of the power rule as well as the negative exponent rule. We'll go ahead and use the power rule first. We'll have y to the negative 4 times negative 3, z to the 2 times negative 3, over x to the negative 7 times negative 3. We end up with y to the 12, z to the negative 6, over x to the positive 21. The z to the negative 6 can't stand because we don't accept a negative exponent as a simplified answer of the laws of exponents unless we're dealing with scientific notation, which I'm going to assure you there's not a scientific notation problem on this test. Okay, so you don't need to worry about that. It's going to be y to the 12 over x to the 21st, z to the 6th. Okay. You guys cool? It's a quiet day without John Call in class. John took the test, got a good grade, sent me a lovely email wishing me aloha as he's going to head to Hawaii, and I am too. Are you feeling sorry for all of us? I hope so. Okay. What's the answer to this problem right here? What's the answer? It's 1, right?
0.
And this is the 0 rule. It is also the power rule. And how is it the power rule? Well, we have a parentheses, powers being raised to powers, but ultimately, isn't that going to be 24 to the 0 and x to the 7 times 0, right? When 24 to the 0 is 1 and x to the 7 times 0 is x to the 0, which is also 1, and 1 times 1 is 1. Listen, anything to the 0 power equals 1. That's the 0 rule. That's the bottom line. Everything in that parentheses will be affected by that power of 0. It will just equal 1. We cool? Okay. If you understand these concepts, you understand those two retro problems. Let's do this realtor problem. Can I erase the Pythagorean theorem problem over here? We all good? We got the pictures we want and need? Let's go ahead and put the camera on the realtor problem. We've seen this on a test before. This really is a simple problem that students kind of give themselves fits over because the answer isn't exactly the answer or any of the multiple choice options, okay? First off, a realtor can use a linear model to predict the price of a house P. So P is the price based on the size of the house S. S is square footage. Assume that for a local real estate market, the equation is P equals 102S plus 22,500. Using this model, which of the following home prices would be reasonable for a realtor who is selling a 1,600 square foot house? Okay, what do I do here? What do I do here? I have P equals 102S. Okay, and that's not a 5, so I'm going to put a little cross through it. And plus 22,500, right?
Yep.
So what do I do with this knowledge that I have a 1,600 square foot house? What do I do?
Well, it stands for S.
Very good. So where there's an S, I'm going to put what?
You're going to put that number and multiply.
Okay, so I have P equals 102 times what?
Multiplied by 1,600.
Very good. So the 1,600 square foot goes where S is for square foot. I do the math. What does 102 times 1,600 make on a calculator?
163,200.
Is that right?
Yes.
Does everybody agree with that?
Yes.
Okay. And that's plus 22,500. So we add those and we get P equals $185,700. That's the price. So listen, where students get kind of confused on this is none of these are that answer. But what's the closest one?
180.
The closest one's 180,000. So that is the correct answer. Now, when we did this the last time, I said, hey, you know, if we're in a good market, can't we charge a little more than the price? And most of the time, if you estimated what you could sell your house for, you'd ask a little bit more. Most of the time you would. But if you were in a really bad market, you might ask a little bit less, okay? So it's not out of the question to go under this amount either. So the point is that it's the closest value to this, okay? All right, good enough. The last two problems on the test. One is to graph a line of an equation. Let's go ahead and look at the next page, review section. So, graph and find the slope from chapter 3. Let's go ahead and just graph number 8. Let's go ahead and graph number 8. Do you want pictures of these on the board here? Any of this? Okay, I'll go ahead and graph number 8 over here real quick. Take a picture of that if you want those laws of exponent problems. But if I ask you to graph y equals negative 1/3 x plus 12, y equals negative 1/3 x plus 12. Okay? All right, so the beauty of this problem is what?
It's already in y mx plus b format.
It's in y equals mx plus b form. So we plot b, which is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right there. And then we're going to use m, negative 1/3, to rise, then run from b. Not from the origin, but from b, the point on the line, which rise is up or down. Which one?
Down.
Down 1 and over 3. Yep, so we'd be about right there. And we could then draw our line, and we're done. So you're going to have a problem like this on the test, where you're just asked to graph a line. Remember, when we had our graphing test, they're going to provide you 4 graphs. It's going to be the one that looks the most like your graph. And you're going to pick it in a multiple choice option. Pretty easy stuff. Okay, I'm going to let you guys review this stuff. But the last question on the test is like number 11 here. Jake has received scores of 84 and 75 on his first 2 exams, right? This is an average problem, but notice it's an inequality problem because they're not just asking for a single score. They're saying what scores would give him an average of, at least, 80 is what they're asking for, right? They're saying keep an average of 80 or greater. So obviously this student's looking for the B grade, B minus or higher in the class. So think about this. Big A for average equals how many total tests has this student taken? 2. Okay? But they're going to take how many total in the class? 3. And we're going to divide that by the number of tests, which is 3. So remember we said we're going to treat it like an equal sign. When we did the average problems that were, inequalities, we said just treat it like an equal sign. So what does A equal? What does A equal? A equals 80. What's test 1? 84. And test 2? 75. And test 3? Well, that's X. That's the one we don't know, all divided by 3. Now we got to solve this. Do we have fractions? Yeah, we do. So we're going to multiply... No. We're going to multiply this side by 3 and this side by 3, which allows those 3's to cancel. And then we're left with 3 times 80 is 240 equals 84 plus 75 plus x. I'm going to combine my like terms. 84 and 75, does that make 159?
Yes.
So 240 equals 159 plus x. And I'm going to subtract 159 from each side. Do I get 81?
Yes.
So I got 81 equals x. Is that my final answer?
No.
No. I have to write it as an inequality, right? Because we don't know, it says 80 or greater, right? Is the average. So I want this to be greater than or equal to. So x is greater than or equal to 81 is my final answer. That's the test, everybody. That's covers all 25 questions on the test. If you felt concerned about what was on this test, you now have a very clear understanding of every problem that you possibly could face. You can see clearly that the practice test gets you everything you need in order to do well. We definitely put a few extra retro problems in there for you. Let's see something here. What problem was that we just did? 11? Okay. Is there anything you guys want to see? We got 2 minutes left. You want to see a method for factoring problems? Do you want to see anything from the first? Yes, Gentile.
So number 11
Mhm.
for the chapter practice test.
Let's do it. Oops. Uh-oh. I don't want that. Number 11. Am I there?
Mhm.
All right. Go ahead and read that problem to me, Gentile.
Okay, x to the third
Yep.
plus 14x squared
Yep.
plus 53x
Okay.
plus 40.
Good. All right. So here we have our 5 methods of factoring. First thing I always do is check for a common factor. So method 1, CF. Okay. X, 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 no X. There's no number here, so there's no numerical common factor. So we check for a common factor, we don't have one. Method 2 is grouping. Grouping is done when we have 4 terms. So we're going to take this and say this is x to the third plus 14x squared, put it in parentheses, plus 53x plus 40 in parentheses. My common factor here is x squared. Agreed?
Yes.
And I have x plus 14. Okay? My common factor over here, well, I have to have this parentheses equal x plus 14, or this is what? It's unfactorable, which is known as prime. Okay, so listen, is there any way I can factor something out of this and just, I'd have to factor 53 out of this to make this x. Well, I would have to have a denomination of 53 over here. It doesn't work. This is prime.
So on the answer key, it showed a different answer. So that's why I was having trouble with it.
That's not good. Yeah, it did. That's number 11?
Yes.
Yeah. That sucks. Thanks, Gentile. Thanks, teaching us that. It's gonna be prime, okay? I don't know what's going on with that. Yeah. Yep, it's just prime. That's all you can do. Unless they change the number there, so that's super frustrating. I would imagine that in the original problem there's supposed to be a different number there, but we'll just say it's prime, so we're good. Thank you. Anything else? All right, guys, we can go ahead and end that video.